The first explosion was catalogued at magnitude 0.0. The second was caught by a satellite designed to look for lightning, in a sky with no thunderstorms anywhere within range. Both happened on the same 900-mile stretch of the United States East Coast, within 48 hours of each other, and both were felt by tens of thousands of Americans who had no idea what they were feeling. In Cambridge, buildings shook. In Boston, police scanners lit up with calls. In Rhode Island, residents compared the sound to an explosion or something massive falling out of the sky. By the time the second event made the news, the first one was still sitting unexplained in a public federal database. And the people who put the pieces together were not federal officials. They were operational meteorologists with public accounts, looking at open data, calling it what it was, because nobody else would. Stay with me, because the rocks are not the real story here. If this kind of investigation is what you want more of, hit subscribe so you do not miss the next one. Drop a comment with where you were when you heard the boom, or what you think hit. Now, let's get into it. At about 2:25 in the afternoon on Saturday, May 30th, 2026, something exploded over eastern Massachusetts. People in Cambridge felt it first. The building shook. Not a tremor, not a passing truck. A hard, sudden, deep thump that came through the floor and the walls at the same time. The kind of sound your body files before your brain does. Within seconds, the same description started coming in from central Boston. Then from the outer suburbs. Then from Rhode Island. Inside 15 minutes, the entire eastern half of the state was trying to figure out what had just happened, and the police scanners in every town within range were lighting up with calls from people who had no idea what they had just felt, only that they had felt it. I want you to sit with that for a second, because this is the part that gets lost in the news coverage. Tens of thousands of people, scattered across multiple states, simultaneously had the same sensory experience inside a 15-minute window. They were not coordinated. They were not watching the news. They were not anywhere near each other. Some of them were in apartment buildings. Some of them were outside. Some of them were on the water. And every single one of them came to the same conclusion within seconds. Something just exploded. Somewhere close. And I don't know what it was. Now, ordinarily, in a country with a functioning emergency communication system, what happens next is that within 30 to 60 minutes, a federal agency comes on the air and tells you what you just experienced. That is how it works for severe weather. That is how it works for earthquakes. That is how it works for tsunamis. There is a national service whose job is to be the voice that comes on after the event and says, "Here is what just happened. Here is what it was. Here is what you do next." That is the baseline expectation a modern population brings to an event of this kind. That voice did not come on. Not for the first hour. Not for the second hour. For the entire afternoon, the only people who could tell you what hit Boston were a handful of meteorologists with public accounts looking at open weather satellite data and putting the pieces together in real time. The federal architecture went quiet. And into that silence, the explanations the public makes up for itself started arriving. And you can probably guess what most of them were. I want to walk you through what those meteorologists saw, because the data is genuinely clean. Sitting in geostationary orbit over the Western Hemisphere is a satellite called GOES-19. GOES-19 is one of the most expensive weather satellites the United States has ever launched. Among the instruments it carries is something called the Geostationary Lightning Mapper, the GLM for short, and that instrument's job is to image the entire visible side of Earth at a wavelength of 777 nanometers, at a sampling rate of about 500 frames per second, looking for the optical flash of lightning. It maps lightning the way a security camera maps movement. Every flash of every storm in the hemisphere shows up on it, in near real time. At approximately 2:25 in the afternoon on May 30th, the GLM logged what was publicly described as a very large flash over eastern Massachusetts. Not a storm, not a string of intracloud lightning. A single, very large, isolated optical flash in clear air with no thunderstorm anywhere near the source location. There was no convection in the area. There were no cumulus towers building. There was no severe weather signature on radar. There was nothing in the sky from a meteorological standpoint that could have generated an optical event of that intensity at that location at that moment. And that is the data point. That is the single observation around which the entire interpretation of this event hangs. Because when a clear air optical flash that bright lights up the GLM, there is essentially one alternative source category: a bolide. A piece of the solar system entering Earth's atmosphere at high enough speed and at a low enough altitude that its terminal fragmentation produced a brief, intense optical signature visible from 22,000 miles away in space. The meteorologists who were watching the GLM data in real time made that call within minutes. They did not wait for a press conference. They did not wait for NASA. They did not wait for a recovered fragment. They looked at the signature. They looked at the absence of any thunderstorm correlation, and they said publicly, "This is going to turn out to be a rather significant bolide entering the atmosphere." That call went out across operational weather networks before any federal agency had said anything at all. And here's where this story stops being about Boston and starts being about something much harder to swallow. Because 43 hours earlier, on the same coastline, something almost identical had already happened, and almost nobody outside of the people who had felt it knew that it had. On Thursday evening, May 28th, at approximately 7:28 Eastern Daylight Time, the United States Geological Survey posted a notable quake entry to its public catalog. The entry was for an event located 6 kilometers northeast of a place called St. Andrews, South Carolina, just outside of Charleston on the coast. The magnitude listed on the entry was M0.0. The label attached to the entry was, and this is the part you need to read carefully, sonic boom. Now, I know how that sounds when you encounter it for the first time. A magnitude 0.0 earthquake is not an earthquake at all. It is what the USGS catalogs when their regional seismic network, that is, the array of seismographs distributed across the southeastern United States that are listening to the ground 24 hours a day, picks up a real multi-station signal that the network is confident in, but where the signal is not the kind of signature you get from rock breaking against rock at depth. It is the signature you get from a pressure wave moving through the air and into the ground. The agency, over the last several years, has formalized a convention for these events. M0.0 with a sonic boom flag, when a real acoustic signal couples into the seismic network from the atmosphere. This is not the USGS being mysterious. This is the USGS being honest about what their instruments saw. The seismic network heard something. The waveform was atmospheric in origin. The agency does not have a process for identifying the source of an atmospheric pressure wave. That is not what the USGS does. And so the catalog entry records what the instruments measured, applies the standard flag, and leaves the question of what actually produced the boom to other agencies. The other agencies did not answer. 43 hours passed. Nobody from the FAA said anything about a supersonic aircraft transit. Nobody from the United States Navy or the Air Force said anything about a training exercise. Nobody from NASA said anything about a planned re-entry. The local news in Charleston ran a few brief pieces on the catalog entry, mostly playing the magnitude 0.0 label for novelty, and the story died. Then Boston felt the second one, and the moment that happened, the South Carolina entry came back. Not because the agencies suddenly had something new to say about it. They did not. And as I am recording this, they still do not. It came back because the audience put the two events next to each other on a map in a 48-hour window on the same coastline and asked the only honest question available. What are the odds of that? That is the question this video is going to answer. But I want to do it carefully, because the easy answers are wrong, and the right answer is more interesting than the easy ones. Before we get there, you need to understand what a bolide actually is. Why a piece of the solar system the size of a beach ball can shake buildings 900 miles up the coastline, and why the two single most important pieces of evidence we have for what hit Boston on Saturday, the GOES 19 flash and the USGS magnitude 0.0 entry, are both data products from instruments that were never designed for the job they are now doing. That is where this story gets harder, and that is where it gets honest. A bolide, in the technical definition, is a meteor brighter than the planet Venus at maximum brightness. That is the literal cutoff. Most meteors, the streaks you see during the Perseids or the Geminids on a clear August or December night, are produced by particles smaller than a grain of rice, vaporizing high in the upper atmosphere at altitudes of 70 to 100 kilometers. They are pretty. They are completely harmless. They do not make sounds. They do not shake buildings. They are, in terms of incoming mass, the snowflakes of the solar system. A bolide is a different category of event. To outshine Venus, an object has to deliver enough energy to the atmosphere in a single flash that, from the surface of Earth, it momentarily reads as brighter than the brightest planet in the night sky. The objects that do this are characteristically tens of centimeters across at minimum, and can range up to several meters across at the high end of what we typically call a bolide. The Chelyabinsk event in 2013, the one over Russia that injured roughly 1,500 people, almost all from shattered window glass, was a bolide. The object that produced it was, by current estimates, roughly 20 meters in diameter. That is at the very high end of the bolide range, and at that scale, the airburst is more commonly described in kiloton equivalent energy. Chelyabinsk released somewhere between 400 and 500 kilotons of TNT equivalent energy in a few seconds. That is about 30 times the energy of the Hiroshima weapon, and every joule of it was delivered to Earth's atmosphere by a single rock the size of a small house, moving at 18 kilometers per second. The Boston event was almost certainly not at the Chelyabinsk scale. If it had been, we would be talking about broken windows across half of New England and a publicly visible smoke trail across the entire region. What the Boston event is consistent with, based on the felt distance reports across multiple states and the magnitude of the GOES 19 flash, is something in the meter class range, an object somewhere between a basketball and a refrigerator, give or take, entering the atmosphere fast, breaking up at altitude, and releasing a fraction of a kiloton of energy as a single airburst. That seems impossibly small for what the residents of Cambridge felt, and that is the intuition I want you to push back against. The thing that makes a bolide audible at ground level is not its size, it is its kinetic energy. A meter-class object hitting the atmosphere at 20 kilometers per second is carrying the energy equivalent of a heavily loaded freight train at highway speed. When that energy goes into a single airburst, the shockwave it generates is a literal sonic event. It propagates outward at the speed of sound. It couples into the ground. It rattles windows. It shakes buildings that are not built to withstand a sudden vertical pressure pulse from above. The reason the boom was heard from Cambridge to Rhode Island is geometric. An airburst at altitude, say 30 to 50 kilometers up, projects a shock cone in every direction at once. The radius at which a person on the surface still hears the boom as a loud event depends on the energy of the burst and the atmospheric conditions. But for a sub-kiloton bolide, a 100 to 200 kilometer audibility radius is well within normal. Cambridge to Providence is about 90 kilometers. Cambridge to the outer Massachusetts suburbs is half that. The geography is consistent with a single airburst at altitude over eastern Massachusetts, with the shockwave reaching the surface across the whole metropolitan corridor and far enough south to bring Rhode Island into the alert window. That is what hit Boston. A small fragment of the solar system, traveling fast enough that its own kinetic energy was enough to release a sub-kiloton airburst at altitude, with the optical signature of the terminal fragmentation visible to a geostationary weather satellite 22,000 miles up, and the acoustic signature reaching every population center within a couple of 100 kilometers of the burst point. I want you to hold that picture in your head for a moment, because the population of objects from which this fragment came is itself a story worth telling. Earth, every single day, sweeps through a debris field that has been accumulating in the inner solar system for 4.5 billion years. The objects in that field range in size, from individual grains of dust to bodies many kilometers across. The smallest of them are the meteoroids that produce visible meteors when they enter the atmosphere. The largest of them are the asteroids whose orbits we track with names and identifying designations. The meter-class objects, the ones in the size range that produced the Boston event, sit in the middle of that distribution. There are a lot of them. They are too small to be discovered routinely by ground-based survey telescopes from interplanetary distances. They are too large to vaporize quietly in the upper atmosphere when they enter. They are the objects that make the news when they arrive, because they are the objects that produce events that the public can feel, but they are essentially invisible to us until the moment they actually hit. The way that population is generated is itself worth understanding. The main asteroid belt, between the orbits of Mars and Jupiter, contains many millions of bodies, large enough to be tracked individually with current instruments. Collisions in the main belt produce smaller fragments. Some of those fragments are scattered over millions of years by gravitational interactions with Jupiter, by the Yarkovsky effect, the very slow rotational radiation pressure that drifts small bodies through the solar system over geological time, and by close encounters with the inner planets. The fragments that end up on Earth-crossing orbits are the near-Earth objects that planetary scientists catalog. The Mount Lemmon Survey, the Pan-STARRS facilities in Hawaii, and the Atlas Network are running continuous surveys to catch as many of those objects as possible before they reach us. The catalog is excellent for the very large ones, decent for the moderate-sized ones, and almost empty for the meter-class population. That is why the Boston event arrived without warning. Not because anybody failed at the job, because the job at that size class is not yet possible. The object that hit Boston on Saturday was almost certainly never seen by any survey telescope before atmospheric entry. It was below the detection threshold of every instrument currently operating. The first time a human eye registered the object was the moment it produced the flash that the GLM caught, by which point it was already in the process of becoming something other than an object. Now, what is the most important thing about that explanation? It is the most boring possible thing that could have happened. It is the explanation that requires the fewest new assumptions. It is the explanation that fits every piece of available data without invoking anything more exotic than the standard physics of meteoroid atmospheric entry that planetary scientists have been describing since before any of us were born. The honest answer to the question of what hit Boston is the most parsimonious one, and it is also probably correct. But that does not mean the story is over, because the question of what hit Boston is the easy question. The question of what hit South Carolina 43 hours earlier is harder. The question of whether the two events are related is harder still. And the question of why nobody from the federal government has told us either answer 2 full days after the first event and several hours after the second one. That question is, in the actual structural sense, the most important question of all. I want to talk for a few minutes about the instrument that, in the absence of any federal voice, ended up being the closest thing the United States had to a planetary defense communication asset on Saturday afternoon. That instrument is the Geostationary Lightning Mapper aboard the GOES-19 weather satellite. The acronym is GLM. The instrument is operated by the National Oceanic and Atmospheric Administration through its National Environmental Satellite, data, and information service. It is not, and was never intended to be, a planetary defense asset. It was built to map lightning. Here's how it works. The GLM stares continuously at the Western Hemisphere from geostationary orbit. That is, from an altitude of about 35,786 kilometers above the equator, an orbit in which the satellite moves at exactly the same angular speed as the Earth rotates, so that from the ground the satellite appears to hang motionless in the sky. From that altitude, the GLM images the visible disk of the planet at a wavelength of 777 nanometers, which is the wavelength of a specific atomic oxygen emission line that is dominant in the optical spectrum of lightning. It samples that image at extremely high cadence, fast enough to catch the millisecond scale flashes that characterize cloud-to-ground and intra-cloud lightning. The instrument is, in essence, a wide-field, very fast, dim-light camera, optimized for catching optical events that last for a few milliseconds. That sensitivity to brief, bright optical events is the reason it can also see bolides, when a bolide undergoes terminal fragmentation in the upper atmosphere, which is the moment when the structural integrity of the object fails under the aerodynamic and thermal stress of high-speed atmospheric entry, and the object breaks apart in a cascade of subfragments that vaporize almost simultaneously. The event produces a brief, intense optical pulse. From the ground, you see it as a flash brighter than the moon for a fraction of a second. From geostationary orbit, the GLM sees it as a very large optical event in a single time bin, at a location that is not associated with any cloud cover or convective signature. The historical precedent for this is the Cuban bolide of February 1st, 2019. On that morning, an object roughly the size of a kitchen table entered the atmosphere over western Cuba and produced a daylight airburst that was felt across a wide area of the island. There were no thunderstorms in the area. There was no operational weather event in the region that could have produced an optical flash visible from orbit, and yet the GOES-16 Geostationary Lightning Mapper, the previous generation version of the same instrument now aboard GOES-19, caught the flash cleanly in a clear sky region of Cuba at exactly the time the audible boom was reported. Within hours, the GOES-16 GLM data was being shared by independent meteorologists. The bolide hypothesis was being confirmed by Cuban authorities, and recovered fragments started showing up on the ground in the town of Viñales. The Cuban event is the canonical example in the modern instrument record of a weather satellite picking up a planetary defense event. The Boston event on Saturday afternoon is the same signature. The GLM caught a very large optical flash. The flash was in clear air. There were no thunderstorms anywhere in the area. The independent meteorologist call was immediate, public, and on the record. The instrument worked exactly as it had in the Cuban case 6 years earlier. The data was in the open. Anyone with access to the operational GOES-19 data product could see it. The bolide call was not speculation. It was the standard reading of an instrument signature that has a known precedent and a known interpretation. It is worth taking a moment to appreciate what we have actually built, even if we have not yet built the voice to talk about it. The GOES series of satellites has been operating in some form for more than 4 decades. The Geostationary Lightning Mapper is a relatively recent addition, first carried aboard GOES-16, launched in 2016, and now also aboard GOES-19. The instrument has, over its operational lifetime, transformed our understanding of how lightning is distributed in time and space across the Western Hemisphere. It has caught thunderstorms that ground-based networks miss entirely. It has revealed previously undocumented patterns of intracloud activity in tropical convection. It has been, by any reasonable measure, an enormously successful scientific instrument. And along the way, it has also caught bolides. Not because it was designed to, because the same sensitivity that lets it pick up the dim optical signatures of intracloud lightning also lets it pick up the bright, brief optical signatures of objects from interplanetary space depositing their kinetic energy into the upper atmosphere. This is, in a way, a quiet pattern that runs through the history of planetary defense. The instruments that have given us the most consequential data about bolide events are almost never instruments that were built for bolide detection. The Defense Support Program satellites in the late 20th century, which were built to detect Soviet missile launches, picked up the optical signatures of hundreds of upper atmosphere bolides over their operational lifetimes, and the declassified subset of that data forms the backbone of the modern understanding of the global bolide rate. The infrasound stations of the Comprehensive Nuclear Test Ban Treaty Organization, which were built to detect clandestine nuclear tests, routinely detect the acoustic signatures of bolides, including the Chelyabinsk event, which they tracked at 20 stations across the planet. The Geostationary Lightning Mapper, which was built to map lightning, caught Cuba and now appears to have caught Boston. The infrastructure for planetary defense detection exists. It has been built for other reasons, by other agencies, and pressed into service by professionals who recognize what they are seeing. What does not exist is the communication architecture downstream of that detection, and we are going to get to that in a few minutes. The question that follows from that, of course, is, if the data was in the open, and the call was being made by independent meteorologists within minutes, and the instrument is operated by an agency of the United States federal government, why was the Federal Communication Channel silent? That is the question we have to come back to, because it is the question this whole video is really about. But before we get there, I want to take you to the second instrument signature, the one from South Carolina, and walk through what the USGS magnitude 0.0 label actually means and why it matters. The United States Geological Survey, through its National Earthquake Information Center, runs the most comprehensive regional seismic network on the planet. The network consists of thousands of seismographs distributed across the United States and operated in coordination with regional partners, universities, state geological surveys, national laboratories. The data from those instruments is aggregated in near real time, processed by automatic algorithms that identify candidate seismic events, and reviewed by human analysts when an event crosses certain thresholds. The result is the public USGS earthquake catalog, which records, locates, and characterizes essentially every detectable seismic event in the United States and its territories. The catalog includes a small but growing class of entries that are not earthquakes. They are flagged with the convention M0.0, accompanied by a label that identifies the actual source category. The most common such label is sonic boom. The agency uses this convention when the regional seismic network has unambiguously detected a real signal at multiple stations that the analysts can confidently characterize, but where the waveform is inconsistent with a tectonic source. The signature of a sonic boom in a regional seismic network is recognizable. The pressure wave from a supersonic event in the atmosphere couples into the ground at the point closest to the airborne source, and then propagates as a surface wave at characteristic speeds. The arrival times across the network, the relative amplitudes, and the frequency content of the signal all carry the fingerprint of an atmospheric rather than tectonic origin. The Chelyabinsk event in 2013 is the canonical demonstration of this. When the Russian airburst occurred, regional seismic networks in central Russia, across Central Asia, and as far west as Central Europe all recorded the signal cleanly. The published seismological literature on the event reads like a textbook on atmospheric-to-ground acoustic coupling. The signal was detected at dozens of stations. The locations of the stations relative to the airburst trajectory could be reconstructed from the relative arrival times. The energy of the airburst could be estimated from the amplitude. The seismic network, in other words, did exactly what it was built to do, even though the source of the signal was an object that had entered the atmosphere at 20 kilometers per second from interplanetary space. When the USGS posted the magnitude 0.0 sonic boom entry for St. Andrews, South Carolina, on Thursday evening, the agency was doing the modern version of what the Russian seismic network had done in 2013. The regional network had detected a real signal. The waveform was atmospheric in origin. The agency cataloged the event accurately and applied the standard flag. What the entry does not contain, and what the entry was never going to contain, because it is not in the USGS's remit to produce it, is an identification of what kind of atmospheric source generated the signal. Was it a supersonic military aircraft? Was it a sonic boom from a non-military supersonic experimental vehicle? Was it an industrial blast at a quarry or construction site? Was it a bolide, like the one that hit Boston 43 hours later? The agency does not know. The agency did not pretend to know. The catalog entry sat in the public record for 43 hours, accurately describing what the instruments had measured, and the question of what generated the signal was left by the Standard Division of Federal Labor for some other agency to answer. No other agency answered. That is the entire structural failure that this video is going to argue is the real story underneath the rocks, and we will get to that. But first, we need to do the part that the audience is going to demand we do, which is to take seriously the question of whether the two events are related. There are three ways to read what happened on the East Coast between Thursday evening and Saturday afternoon, and I am going to lay all three of them out for you, in the order of how much explanation each one requires. I want you to keep track of which one you find yourself reaching for, because the one you reach for first tells you something about how you read the world. The first interpretation, call it Interpretation A, is that the two events are unrelated sporadic bolides, both atmospheric in origin, both within the normal background rate of subkiloton terrestrial impacts, and that the clustering is a coincidence that registered with the public because the events happened to be witnessed by populated coastal corridors. Under this reading, the GOEA's 19 GLM signature on Saturday is the strongest piece of evidence we have, and the South Carolina event on Thursday is most likely the same kind of event, just without an accompanying publicly visible GLM call. This is the boring interpretation. This is the one where the universe is not telling us a story. This is the one where two rocks fell out of the sky in the same week, and that's all that happened. I want to give you the math, because the math actually matters here. Earth's atmosphere is hit by an object large enough to produce a visible fireball. That is, a bolide brighter than Venus, somewhere around once every several hours, averaged over the whole planet. Most of those events happen over ocean. Most of the rest happen over uninhabited land. A small fraction happen during the day, when the optical track is washed out by sunlight, and only the terminal flash and the boom are detectable. Even smaller fraction happen over populated areas. The result is that boom-class bolides, events that produce an audible airburst at the surface, happen several times a year globally, and most of them go unreported because nobody was there to hear them. The probability of a given populated metropolitan corridor being witness to a single such event in a given year is small. The probability of two events on the same coastline within 48 hours is, on the order of magnitude argument, in the very low percentage range. It is not impossible. It is not even particularly rare on the global scale. But it is uncommon enough that the human pattern matching apparatus is going to read it as anomalous, and that reading is not wrong. It is just not necessarily evidence of a deeper connection. The second interpretation, Interpretation B, is that the two events are unrelated, but that one or both is not actually a bolide. The South Carolina event in particular is genuinely underconstrained by the public data. The USGS catalog entry tells us that the regional seismic network detected an atmospheric pressure event, but it does not tell us what generated the pressure event. Candidates include a military supersonic aircraft transit along the Atlantic coast, an industrial blast at a coastal facility, a sonic boom from a non-military experimental supersonic vehicle, or any of several other plausible atmospheric sources. Under this reading, the Boston event on Saturday is still a bolide, on the strength of the GLM optical signature, and the South Carolina event was something else, and the news framing of two of the same kind of event is a coincidence that has partly been amplified by the human urge to find patterns. This interpretation requires fewer unknown variables on the Boston side, but more unknowns on the South Carolina side, and it is a defensible reading of the limited data we have. The third interpretation, interpretation C, is the one the comment section is going to gravitate toward. And I want you to hear me out before you decide whether to dismiss it. Interpretation C is that the two events are physically related, not in the conspiratorial sense, in the astrodynamical sense. The idea is that the two events might be members of the same small meteoroid stream, fragments of a single parent body that has just begun to deliver pieces to Earth's atmosphere along a coherent trajectory, or that they share some other dynamical connection that places them on the same family of orbits. I want to be very careful about how I describe what we know about this hypothesis. There is, as I am recording this, no published orbital tie between the two events. The American Meteor Society has not announced a coherent radiant for a stream that would explain both. The major meteor showers visible from the United States this time of year, the Areatids, peaking around June 7th with a daytime radiant that hides them from naked eye observation, and the Eta Aquariids, which were peaking on May 5th and 6th, and would be on the decay tail at this point. Neither of those streams is known to produce boom-class bolides. The seasonal meteor shower calendar does not support a single stream explanation. That does not mean interpretation C is impossible. Small, recently broken parent bodies can deliver streams that are not on anyone's calendar. But it does mean that interpretation C is the one with the least direct evidence, and the most reliance on a connection that the data does not yet show. The honest position is to lay all three interpretations out. Give interpretation A as the leading candidate on the basis of the published data. Treat interpretation B as a reasonable alternative for the South Carolina event specifically, and acknowledge interpretation C as the one to watch. Because if a third event occurs within the same window on the same coastline, interpretation C becomes much harder to dismiss. If you take only one thing from this section, take this. The next 72 hours are the data point. If nothing else happens, the most likely reading is that two sporadic bolides arrived in the same week, and the world moves on. If a third event happens, and I do not want to be the one who predicted it, because the responsible posture is to wait and see, then the conversation shifts, and it shifts permanently. Before we get to the part of this video that I think is the most important part, I want to do something that the responsible thing to do is in any TQA story of this kind, which is to take seriously the alternative framings that the audience is going to bring to this event, and then walk through what the actual data says about each one. The first framing that always comes up in stories like this is the idea that the events were triggered by something happening on the sun. This is not a crazy question. There is a subliterature, going back several decades, that has investigated whether geomagnetic conditions can correlate with the timing of seismic events, and the Marcatelli 2020 study in Scientific Reports is probably the most cited modern paper on the topic. The framework the study proposes requires specific preconditions. Geomagnetic driving from an Earth-directed coronal mass ejection, paired with active solar wind conditions, paired with elevated geomagnetic activity in the days surrounding the seismic event. Those preconditions, when they are present, are at least worth asking the question about. I want to tell you what the preconditions look like over the May 28th to May 30th window. The KP index, which is the standard measure of geomagnetic activity, peaked at 4 on May 29th at 1800 Universal Time. That is below the G1 minor storm threshold of 5. There were no Earth-directed coronal mass ejections in the published Space Weather Prediction Center catalog for the window. The solar wind speed at the time of the Boston event was about 522 kilometers per second, which is mildly elevated but not in storm territory. There was one M-class flare in the preceding 3 days, an M1.1 event from active region 4455 on May 29th, but the source location was at 14 degrees north and 62 degrees east on the solar disk, which is well east of the central meridian, which means any coronal mass ejection associated with the flare would have been directed away from Earth, not toward it. The framework conditions for any solar trigger interpretation are simply not satisfied. The driving inputs that the framework requires are not present in the data. That does not mean the question is illegitimate to ask. It just means that on the published data, the framework conditions are not there, and the interpretation cannot be supported by the standard analysis. We are not in a state of active geomagnetic driving. The sky is, by the standard measures, quiet. The second framing is the engineered atmospheric event idea, the suggestion that the two booms were produced by a directed energy weapon, an experimental ionospheric heater, a high atmosphere experiment, or some other deployed technology of the kind that the conspiracy-adjacent corner of the internet has been talking about for decades. I want to apply the same energy budget physics I have applied across other stories on this channel, because the math here is straightforward and the math does not close. A Bolide event produces an optical flash whose energy is in the 10 to the 10th to 10 to the 12th joule range over a few seconds. That is consistent with the GLM detection on Saturday. A hypothetical directed energy weapon at the scale required to produce a multi-state felt acoustic event would require continuous power delivery into the upper atmosphere at levels that are not within the operational capability of any publicly disclosed system, and would produce a sustained signature, not a single flash. A facility on the order of the most powerful publicly known ionospheric heater operates in the megawatt range and would need to deliver many orders of magnitude more energy than that to produce a felt acoustic event across the kind of multi-state geography we are talking about here. The math on these alternatives is the same math I have walked through in earlier stories. The energy budget does not close. The signature does not match a sustained source. And the parsimonious reading of the data is the Bolide reading. The third framing is the idea that the events were a military exercise that simply was not announced ahead of time. This one is a closer fit to the South Carolina event than to the Boston event, and I want to give it the honest treatment. The U.S. military operates supersonic flight profiles routinely, and those profiles do occasionally produce booms over populated areas in violation of intended operating procedures. It happens. The Pentagon, when asked, will sometimes acknowledge such events after the fact. But for the Boston event specifically, the GLM optical signature is what makes the military exercise framing not work. A supersonic aircraft does not produce an optical flash visible from geostationary orbit. The boom of a supersonic aircraft is a shockwave event without a corresponding optical pulse. The fact that the GLM caught a very large optical flash at the same time as the felt event is what distinguishes the Boston event from a candidate military exercise interpretation. The instrument is telling us that whatever made the boom also made a light, and supersonic aircraft do not make lights. The fourth framing is the idea that the events are related to something in the cryptid or interdimensional or unidentified aerial phenomenon space, that the booms are evidence of a portal opening, an underground entity surfacing, an unconventional craft transiting the area. I am going to dispatch this the same way I always dispatch this category, which is to point out that extraordinary claims require extraordinary evidence, and the GLM data is not extraordinary evidence of anything other than a bright optical flash, consistent with the well-understood physics of bolide atmospheric entry. We do not need to invoke a more complex hypothesis when the simpler one is already supported by the published instrument data. The audience is asking the question because the audience is paying attention, and that is a healthy thing. But the parsimonious answer is the right answer here. That brings us to the fifth and final framing, which is the one that we have been circling for the whole video, and which is the one I want to spend the closing of this story on, because it is the framing that actually matters. The framing that the government knows what these events were, and is not telling us. I want to be very careful here, because the honest answer to that fifth framing is not the answer that most of the audience is expecting, and it is also not the answer that the official spokespeople are going to give. The honest answer is this. The United States federal government does not have a designated agency whose job is to publicly communicate when a piece of the solar system has just exploded above an American city. There is no Bolide Notification Center. There is no Planetary Defense Public Affairs Office. There is no number you call when GOES-19 catches a clear air flash over a metropolitan area to find out within an hour what just happened. The architecture for that kind of communication, for that kind of event, does not exist. It has never existed. What exists, instead, is a constellation of agencies, each of which holds a piece of the relevant data, and none of which has the formal authority to issue a public bolide identification. NASA has a Planetary Defense Coordination Office, which is staffed by scientists, which does excellent work on near-Earth object discovery and characterization, and which is not set up to be a real-time public affairs voice for atmospheric entry events. No AA operates the GOES-19 satellite and its lightning mapper, but the public-facing identification of a GLM flash as a bolide is not part of NOAA's operational mission, which is weather. The USGS catalogues the seismic signature when the boom couples into the ground, but identification of the source category beyond the sonic boom flag is not in the USGS's remit. The FAA tracks airspace activity and can rule out announced aircraft sources, but does not have a process for affirmatively identifying a non-aircraft event. The U.S. Space Force tracks orbital debris and decaying re-entries, but a small bolide on a hyperbolic atmospheric entry trajectory was never part of an orbital catalog and is not visible to space surveillance assets until it is already in the atmosphere. Each of these agencies has a piece. None of them owns the communication. When the Boston event happened on Saturday afternoon, the actual chain of public knowledge ran from a NOAA satellite, through a NOAA data product, to a set of independent meteorologists with public accounts, to a public hypothesis that this was a bolide. The chain did not pass through any federal communicating voice at any point. It worked because individual professionals, looking at open data, made the call. It did not work because any of the relevant agencies acted in their public communication role, because none of those agencies is set up to act in that role for this category of event. That is the structural reading. The two events on the East Coast in 48 hours were not suppressed. They were orphaned. The federal architecture for telling the American public what just happened, when the thing that just happened is a piece of the solar system, is a structural absence. It is not a cover-up. It is not a deliberate silence. It is a category of event for which the United States simply does not have a designated voice. I want to sit with that for a moment, because the implications are worse than the implications of the conspiracy framing. If the government were actively suppressing information about bolide events, that would at least mean the information existed somewhere inside the federal architecture and was being held back by a decision. The actual situation is that the information does not exist as a federal product. It exists as a derived inference made by independent operational meteorologists with public-facing accounts working from open data. The agency that would have made the call, if there were an agency, simply does not exist. And here is the part that I think you should carry out of this video, because it is the part that nobody else is going to put in these words for you. The two events on the East Coast in 48 hours were small. They were felt. They were frightening. They were a fraction of a kiloton each, almost certainly, And the worst damage anyone has reported as I am recording this is a level of building shake that did not break windows in any large numbers. They were, on the global rate of bolide events, well within normal. They were a couple of pebbles from the solar system, arriving at terminal velocity on a coastline that happened to have enough people on it to feel them. The next time something like this happens, it might not be a couple of pebbles. The Chelyabinsk event in 2013 was 30 times the energy of the Hiroshima weapon. The Tunguska event in 1908 over Siberia flattened roughly 800 square miles of forest. The objects responsible for those events are drawn from the same population of meter-class and larger near-Earth objects that produced the Boston event and probably the South Carolina event. We catch around 90% of the 1 kilometer and larger objects. We catch about 40% of the 140 meter and larger objects. We catch a single-digit percentage of the objects in the size range that hit Boston on Saturday. We catch almost none of the objects that come at us from the daytime sky because the sun blinds our detection telescopes against the bright background. Chelyabinsk came from the daytime sky, and we did not see it until it lit up over Russia. If a larger version of what hit Boston arrives over an American city in the next several years, and given the population of objects out there and the increasing precision of our detection arm, that is a meaningful probability over a multi-year horizon. The communication architecture that failed to identify the Boston event within the first hour is the same communication architecture that will fail to identify a much larger version of it. The federal voice that did not come on the air on Saturday afternoon is the same voice that will not come on the air the next time. The gap is structural. It has not been closed. So when you hear in the next several days the inevitable analysis that the 2 East Coast booms were unexplained because the government wanted them to be unexplained, I want you to remember what I just walked you through. The instruments worked. The catalog worked. The independent meteorologists made the call. The data was in the open. The only thing that was missing was a voice, a federal voice, an official voice, a single human being whose job is to come on the air and say, here's what just happened to you. That voice does not exist for this category of event in the architecture of the United States government in the year 2026 with a tens of billions of dollar weather satellite literally watching the sky. That is what the 2 booms reveal. Not a conspiracy, not a cover-up, not an enemy weapon, not a portal. A structural absence in the most powerful technological state in human history for the question of what is hitting it from above. The rocks are not the story. The silence is the story. And the silence is going to keep being the story. Every single time a piece of the solar system explodes over an American city, until somebody in Washington decides that the species of event that just happened twice in 48 hours over the East Coast deserves a voice of its own. Until then, the only people who are going to tell you what just hit you are the same people who were already watching the sky for thunderstorms. That is the real anomaly, not the rocks, the silence. The real question is not what hit Boston on Saturday. The real question is who is supposed to tell us, and why we have to wait for the people who watch thunderstorms to do the job that nobody else in the federal government has been assigned to do. Until that gap is closed, every single one of these events is going to feel, to the public, like a cover-up. Because the federal silence is structurally indistinguishable from a deliberate silence, from the perspective of anyone on the ground waiting for an answer that is never going to come. And the longer that silence holds, the harder it is going to be for the American public to believe, the next time a much bigger one of these lands, that there is no one in charge of the sky. The truth is that there is not. The truth is that there has never been. And the truth is that on Saturday afternoon, the closest thing the United States had to a planetary defense communicating agency was a couple of meteorologists with public accounts, looking at open weather satellite data and putting the pieces together in real time, because nobody else was going to. That is who told us the rock was a rock. That is who is going to tell us next time. And until somebody decides to close the gap, that is the entire architecture we have for the next one.